Drainage recycling is taking several practices and putting them into one. You have a subsurface drainage system, okay, there's one. Then you have a pumping plant to harvest the subsurface water. And then you have a pond or a reservoir to store the water. And then you have a irrigation pump to pump the water back to irrigate it.
Drainage water recycling is going to be most beneficial where there's a clear crop production benefit from both drainage and irrigation. And while irrigation isn't typical in most of our Midwest soils that need drainage, there are some soils that are shallow or have low water holding capacity where irrigation would often be beneficial, especially in areas where typical rainfall between July to August is less than about 5 to 6 inches. And with projected changes in our climate and precipitation patterns, we'll likely see more sites in the Midwest that could benefit from this practice.
Finding places in the landscape for a reservoir will be a challenge. There may be opportunities in portions of a farm that are less profitable or inconvenient to farm, such as wet depressional areas or the center pivot corners that are not irrigated. Some farms might have existing ponds or lagoons that can be repurposed for storing water, and construction costs will be lower where less excavation is required and cut and fill can be balanced.
There are standards and specifications for every part of the project out here. The pond, the subsurface drainage system has a certain drainage coefficient, which dictates how big a main do we need. The type of soils dictate like how close the tile spacing needs to be, not only for drainage, but for irrigation purposes. Building the pond, for example, having certain side slopes that meet safety requirements, having a certain wide berm so that the dam doesn't breach and cause safety issues. We have 3 main tile on this site here. They all go into a pumping plant. That pumping plant, in this case, has a pump that pumps over 1,000 gallons a minute. That's how much water we're gonna have coming here when this system is flowing full. Typically, you get an inch of rain, it's not gonna flow full. It's when you get that big rain, and that's when you need that full capacity of the pump. The pond is designed to store water that is harvested from the subsurface drainage system from September through end of May every year. So in an ideal year, if we've had the normal rainfall we've had and it hasn't been dry, the pond should be fairly full at the end of May.
With the drainage water recycling practice, you can use the water that you store basically for 4 different ways of irrigation. You can use on-surface drip irrigation, which is what we're doing here in southwestern Minnesota. You can use subsurface drip irrigation. You can use overhead irrigation, or you can use sub-irrigation through the drainage system.
We've targeted a sub-irrigation system because we're already installing the tile lines for drainage. So we already have a portion of the infrastructure already installed. When you're installing a free drainage system and then looking at retrofitting it for a sub-irrigation system, we're usually installing the pipes at half the spacing that's required for free drainage. So if I was installing pipes at a 60-foot spacing for drainage, I would put them in at a 30-foot spacing for sub-irrigation.
The other thing is when you start thinking about efficiency of the water use and some of the cost. So all of these types of irrigation, whether they're on the surface or subsurface, there's a cost associated with it, and that needs to be well thought out in advance because it's not inexpensive to be able to go out and irrigate, because you have to have the irrigation equipment to be able to do this, as well as having the system in place, whether it's on the surface or underground, in order to be able to do it. So that can kind of create some economic perspectives that people need to have before they jump in and start doing it.
Anytime you start to dig dirt, you have certain rules and regulations, and every state, every township can be different. In Michigan, under a permitting process, agriculture is exempt unless they build a pond that's bigger than 5 acres in size and has a water level that's 10 feet above the ground. In this case, we're 4.9 acres and we only have 8 foot of water above the ground. We have 8 foot below and 8 foot above. Some of the things that we needed to do is involve the pipeline because we had infrastructure to put in. The pipeline's here, they have easements, they have rules and regulations on what you can do there.
permitting was having to be done. The U.S. Army Corps of Engineers had to give a wetland determination, which was obtained through the NRCS. From that point, the NRCS designed this project and the pattern tile system in the upland hills. They did the soil samples on the dam itself. They did find spots where the soil was not conducive and they were afraid that there was going to be seepage, so we had to do a little bit more of a core trench so this spot would not seep through for the program.
The biggest challenge was constructing a reservoir in a wetland. We wound up buying some wetland credits to build a wetland. You know, my advice to people out there that are thinking about this and wanting to implement this practice, if they're gonna build a reservoir, is start plenty early. I think we spent over 2.5 years from the process of a theory and talking about it to moving dirt.
The local conservation district, every ag county I think has one in the Midwest. It would be a good starting point from a technical service standpoint. Your tile contractor is another contact for this.
There are programs that are available through NRCS, the Natural Resources Conservation Service, that can provide cost share for the implementation of drainage water recycling. The program doesn't pay for the irrigation system per se, but what it does help supplement is the construction or building of the reservoirs in order to be able to have places to be able to store and retain water.
There are multiple resources to learn more about drainage water recycling, such as the Transforming Drainage Project, the tools that project has developed, the Conservation Drainage Network, and also the recently revised NRCS Code 447, Irrigation and Drainage Tailwater Recovery.